Hello and welcome to the next edition of the BobCAD-CAM webinar series. Today's topic is 3 types of profiles. The goal of today's webinar is to learn about the 3 types of profiles and how to use them. As you know, my name is DePoalo. I'm the voice of the Bobcat After Dark video series. You can find me on Instagram at BobCAD-CAM. You could also search hashtag BobCAD, hashtag BobCAM. Now, what are we going to learn today? Today, we're going to talk about the 3 types of profiles you can use within the BobCAD software. There's a standard profile, there is contour ramping, and there is side roughing. So we're going to go through that together. Lots of different ways you can use these types of profiles. As you know, with BobCAD, you can always expect fewer steps, better cuts, and more profit. Now, we do have a Refer a Friend program still going. If you guys have a friend that may be interested in the BobCAD software, you can call 877-333-4903, and you can get a free seat of the software by referring a friend. Call today to find out more. Now, the way that you communicate with me in the GoTo meeting is through the questions area. You're going to write in some questions there, and that is how I'm going to know. Any comments that you have. That's how you communicate with me. If you guys are on Facebook, there is a message area there. You can comment, and that is how you can communicate with me. We are broadcasting this both through the GoTo meeting platform and then also on Facebook. So again, I want to thank each and every one of you for spending some time with me here today. Let's see here. What I'd like to do at this point is go ahead and do a quick shout out. So if you could just let me know your name and where you're from, that'd be great. Let's see. We got Mike here. Larry's from Tennessee. We got Grant. Bill from Texas. Larry from Illinois. We got Reginald, David, Jim, Hugh, Tom from North Carolina. Again, I want to thank each and every one of you for spending some time with me here today. This is Webinar Wednesday. Again, today's topic is 3 types of profiles and how to use them. Hey, Vic from Ohio, thank you so much. John from Palm Harbor, Florida, very good. We got Ron out of Ambler, Pennsylvania. Jim in Ontario, thank you so much, each and every one of you. I really appreciate you spending some time with me here today. So let's go ahead and just jump in. The first thing that I really want to get into, I have some geometry set up here, and I'm just using wireframe. Okay, guys, one of the things that's really powerful about the BobCAD software, whether you're drawing, whether you're importing, hey, Alan, I see you from Missouri there, very good. We got Seth out of Tarpon Springs, Florida, thank you so much. And we'll definitely get into some plasma webinars for you as well, so thank you for joining us here. But one of the things that I wanted to talk about real quick is with the BobCAD software, it's both CAD and CAM, and one of the things that makes it a really quick and fast system to use the program parts is being able to work off of wireframe geometry. You can draw sketches very quickly. I know in today's modeling age, there's so many 3D models, and those models are all, awesome to use, but sometimes many of us are still working off of blueprints, and a lot of times we're drawing parts on the fly. So for today's example, I have a 6x4 rectangle that I've drawn here, and I have a couple of different iterations, different geometries that we're going to talk about. So let's get into it. We're going to get into the CAM tree here. We'll go to Mill 2-axis. From here, we're going to select our geometry. Okay, so using select geometry, we can select what we want to cut. The first one I'm going to look at here is just a rectangle with some radius edges. This is a really common thing to do. Now, one of the ways we could do this is to select all the way around the part, and you could see what I'm doing here is a shift click. So if I hold shift and I left click on the profile, it'll go all the way around the part. But in today's example, instead of doing that, what I want to do is I want to start on this radius and cut to there, and then I want to go from this radius and cut to here. All right. So I just want to put radiuses on the end of the part. If I look at my chain number 1, I can see my cutting direction, so I have it climb milling. If I look at my chain number 2, I can see its cutting direction and it's climb milling. Now, if you want to change the direction of the chain, you can just click on the arrow and it will switch which direction it's going. So let's make sure that these are going the proper direction. We're going to leave the 1/2 inch depth. We're going to choose OK. Now, when we get into our machining strategies, this is where you're going to choose which tool paths you're going to use. Today's example, we're going to just look at profile rough. When we get into the profile rough, really it's this pattern section. This is where we find the three types of profiles. Okay, so we find them under patterns. You have standard, which is the default. You have contour ramping, which you could also call it helical milling, where you're going to ramp down. And then we also have side roughing. Side roughing is where we're going to, we have extra material and we want to take multiple passes. So these are actually very powerful tool paths. You're going to use these all the time. There's a lot of different ways that you can use these three profile tool paths to machine your parts. Okay, so let's start with the first one. We're going to just do a standard profile. We're going to choose next. We have a side allowance, a bottom allowance. Not too concerned with our side allowance or bottom allowance at this time. I do want to take a look at my leads. I'm going to go to a blended, actually circular tangent lead will be fine, and then I'll compute this. Okay, so what this is going to do is the tool's going to come in, and it's just going to walk around the radius of the part there, and then it's going to walk around the radius of the part there. Let's go ahead and launch this into a simulation. So we'll load simulation up real quick, and we can see that the tool, we have the tool and the material. We could load in fixtures and things like that, but this is just fine. We're going to run this through, and you'll see that the tool will start on one side of the part, and it's just going to put this radius on the part. Once it's done with the one side here, it will go over to the other side and then machine that side there. Okay, so that is just a standard two-axis profile. The only thing that we did a little bit differently here is we did only select the ends of the part here. So we only selected the ends of the part, and we did pretty good. So that's the first one. That's a standard profile. If there's any questions about that, go ahead and fire away. Otherwise, we're going to move into our next little bit of geometry. Okay, so now we're looking at a similar part, except the difference is we have some extra material that we're trying to clear in these corners here. So let's remove our selection and reselect. So let's say it's this one, this one, this one, and this one here. Okay, we can recompute. When I recompute, you can see it move to the inside. Generally, when you select your geometry, like a pro tip, it will look at it like it's inside geometry, okay? And it's okay. If these things happen, you just go to the default chain start point here. You can right-click and modify, and then you can just click on these arrows. See, if I want to change the direction that it's cutting, I just click on the arrow in the direction that I want to change it to. Once I have them all set, I'll hit my space bar, and then from there I can compute my tool path. And here you can see in this routine here, the tool's going to come in, but unfortunately, it's not going to clear all the material. We're getting a very similar type profile, but it's not clearing all the material. Let's run this through a simulation real quick and take a look at what's going on. Let's see here. We'll slow this down a little bit and we'll press play. And what we're going to do is, I'm running some resources. It's not loading as quickly as it normally would, so I may turn down my resolution in order to get it to run a little bit quicker. Okay, so if you look at this, you can see that it's profiling and it's following that edge there, but there's actually more material left. So we're not able to clear all of that material. John has how do I switch the simulation so the tool moves and not the part? That's a great question there, John. If we go under workpiece, you have your first three icons on the nav bar here. So material removal, NC mode, and your workpiece selection. You can set this to tool, and by setting it to tool, what will happen is the material will move around and the tool will stay the same. Hey, thank you so much, John from Claremont, joining us here today. So again, under the simulation setting, if you make this tool focused, the material will move and not the tool. So that's how that handles that, Ron. Again, it's running a little slow for me here this morning, or this after morning. So what I'm going to do is come into my simulation settings here. I'm going to go to my Cut Sim tab. you can see I have my accuracy of my simulation turned all the way up. So I'm just going to turn that down a little bit. When I turn that down, I will need to refresh or restart. And by doing that, I expect it to run a little bit faster than it has been. Yep. And here you can see just by turning the resolution down, it's going to run a little bit faster. Okay, so if you guys are noticing that as well, you can turn up the resolution in order to get a more accurate simulation. You can also turn it down so it doesn't bog down your system resources. Okay, so let's go to a top view here. And clearly we can see there's some extra material left over. So doing a single pass on this corner here is not going to clear all the material. So what are we going to do about that? We're going to go ahead and change that. And this is, so the first type of profile was a standard profile. The second one here, this is we're going to go into patterns here, and we're actually going to go to side roughing. Okay, so side roughing is a way for you to take multiple passes on your profile. So I can give it, an amount of material that'd be left. So I'm going to say, let's say a 1/2 inch. Normally I would measure it. And then you have your number of passes. So I'm going to say do that in 3 passes. And I can recompute here. And now you can see we have multiple passes to come in and out. Now, another thing that I should be able to do here, you can see that this is my selected geometry here. And then I do have a lead in, and it's leading in right to that edge. I may want to extend this edge out a little bit further. There is this extension at start and finish right here. This is in the version 30. You have these extensions. So what we can do is use that to extend where the tool will start and finish from. So it's just going to extend this out by greater than 50% of the cutter. And you can see how now that is extended out there. Okay, so that way we're not leading in right to the edge of the part. Okay, so this is an example of our side roughing here, where we're able to take multiple passes to clear the material. It looks like I have a little more material than a 1/2 inch. So I'm just going to set this to, let's say it's 1 inch, and we'll take it in 4 passes. Okay, so now when we look at our material, you can see I'm able to clear all of the material. Now, the downside of using side roughing like this is it's not as efficient of a tool path. If we did an open pocket, like last week's webinar where we talked about the advanced pocket and open pocketing and working its way in from the outside, that one would be trimmed to the stock material, where you can see with this one here, it's actually we're getting wasted tool motion. Okay, so again, you have to look at the right tool path in the right scenario. All right, if there's any questions about side roughing, go ahead and fire away. Otherwise, we're going to move on to the next one. What would you do if you're running version 29? Grant, if you're talking about the extension, you would actually trim the geometry if you're talking about the extension. As far as the side roughing does come standard with the software. So you'll have no problems just choosing that pattern, okay? All right, so here, again, we're doing our side roughing. We're working its way in from the outside. Let me pause this. I prefer workpiece focus. It's a little easier for me to see what's going on. So we'll get this centered up, and we'll play this through. And again, you can see it's going to take multiple passes to come in from the outside and to clear this material, all right? So we have our standard profile, and then we have our side roughing. Okay, so in this case, we're trying to clear these chamfers off the side, and we're taking multiple passes in order to do it. Okay, all right, if there's any questions about that, go ahead and fire away. Otherwise, we're going to move on to the next one. All right, so if we look at this example here, this one's a little bit harder to tell what's going on. So what I'm going to do is I'm going to remove my geometry selection. And what I'll do is I'll select these ends here again. All right. This time I'm going to edit my tool. Okay. So instead of using an end mill, I'm going to come in here and I'm going to load in a T cutter. One of these here. All right. So there's going to come times where you guys may need to do some undercutting. Okay. So that's what we're looking at here. We have a T cutter. We want this T cutter to come in, and it's doing an undercut throughout the part. Let me see. I don't know if I'm gouging on my lead in. I may need to extend that. So let's take a look at the simulation. You may need to do an undercut. It could be like an O-ring groove. It could be some kind of just relief. It could be part of the part marking here. It could be an aesthetic feature. But in this case, we're using a T cutter to come in. Again, with our profile, we're just using a different style tool. And we're able to come in and do this undercut here. All right. So using your standard profile with a different style cutter, you could come in and do an undercut. Maybe it's not a T cutter. Maybe it's a lollipop cutter. So we can add one of those. Let's see. One of these here. We'll recompute. We'll run this through the simulation again. This could be with a lollipop cutter. Again, you got to pay attention to, the clearance that you have here. This one, it looks like I would need to adjust my depth slightly, but you can use a lollipop cutter. It could be a dove mill. You might be doing, a dove mill there, so we can come in and change this to like a dove mill. Let's grab one of these. We'll run a compute on that. We'll run this through the simulation. So when you're doing your profiles, you're not just limited to using your standard tooling. You have a variety of different tools that you can use with the software. You definitely have to pay attention to what your settings are here. Here we can clearly see the shank of the tool is rubbing against that profile. Okay. But at the same time, you can also see with our dove mill, we're getting a negative draft there. So with our right tooling, we would be doing a good job. All right. And then again, there may be times where you can't take all of that material in one shot. So instead of doing a standard profile, you'll go to side roughing. You can say how much material is being removed, how many passes you want to take it in. And then this will walk the tool in. We'll run this through again. This will walk the tool into the profile. Okay, so by walking the tool into the profile, instead of it taking one more aggressive cut, what you're going to end up with is 2 cuts or 3 cuts or however many you put in there. Okay, so you can see it took the 1 pass, and then now it's taking the 2nd pass here. Let me make some adjustments here. Let's edit this. Tool, let's see here, 1 diameter, flute length, angle. And it doesn't look like I have a shank diameter in this one. So one of the things that you'll notice with your tooling, if we go into our tool page here, you have end mills. End mills can be ball end mills, bowl nose, but they also can be form cutters. At any time you're trying to set up a tool, you're going to see this section here called assign geometry, assign tool geometry. And then that way you can set custom tooling that may be outside of the parameters that you see within some of the standard tool calls. All right. So I'm not going to go through that here today, but definitely something that you should be aware of. All right. So let's move on. So we did a standard profile. We did side roughing. In this case, we talked about an undercut. Let's go back to our T cutter here. So we'll grab this T cutter. Let's look at our side allowance. Let me go ahead and 0 that. Let's look at our depth of cut. I'm going to make this 250. I'm going to recompute. Let me edit this feature. So what do I want to do here? Let's turn that off. And I want this to be just a single pass. So we'll go to standard and recompute. All right. So now, even in a situation like this, you may want to take multiple passes. I know a lot of times users, like when they're dealing with T cutters and they're trying to come in and create these undercuts, the tool is going to be driven by the bottom of the cutter. Hello, Simon. Nice to see you in today's webinar. So the tool would be driven by the bottom of the cutter. So if you want to take multiple passes, you do need to think about it a little bit, the thickness of the T cutter that you're using and how many passes that you want to take, because you have to look at the top of the tool as well. The other thing you can do too, once you have one down, you could add a toolpath pattern. You might do a translate. You could say Z minus 250 and make 2 copies or something like that. And that's another way to come at it. Where or you could also have it start at the bottom and you could go up. Where maybe what we did here is we actually want to make 1 copy, and then in order to get to our overall thickness, we might add a 100th. So you do it on the bottom, and then you have it go up and do it from the top. Okay, so using your toolpath patterns, that can definitely be helpful with laying out some of these situations. So if you've haven't used toolpath patterns with your toolpaths, I would definitely recommend it. If you guys aren't using the toolpath editor as well, highly recommend that one too. Let's see if I didn't totally botch this. I wasn't really paying attention to all my settings here. I think I needed it to be a 1/2 inch. But yeah, you can see how we're able to take multiple passes. I did one on the bottom, and then because I used the toolpath pattern, I was able to move one up. If we drop this down, let's edit this and make this a 1/2 inch value and recompute. We'll run this through the simulation again. So I'm doing one cut on the bottom, and then I'm having it step up 100th, and then doing another cut on the top. Would it make more sense to do the top cut and then the bottom cut? Sure, maybe. It all depends on the application, and again, getting to that proper measurement that you're looking for there. Okay. All right, so that is an example of using the toolpath patterns and also using side roughing for an undercut. Now, the next one I want to look at here is a similar scenario. Let me get back to this setting here. What we're going to do first is let's remove. We're going to select this as the dotted line. So this is going to be an open pocket. So we're going to select from here to here. This one, we're going to make a pocket strategy. This is going to be advance, and we'll go 2-way and compute. All right, so that will clear all the material for this boss. And then what we want to do is like an O-ring groove or something along those lines around this boss. So that's where we'll use another profile. We'll select our inside shape here. This will, let's say it goes down 1/4 inch. We're going to do just our rough profile. We'll go to our T cutter here. So we'll pick up our tool. We're going to, let's see, leads. We'll do tangent. That's fine. Okay, so we're going to get this going the right direction. You can see I'm kind of went through it kind of fast. So I want to get the tool going in the other direction. So I can just reverse it by going to the chain start. And then now we can see we have that. Let's go ahead and blank our pocket out here. So we'll blank this one out. And what this is going to do is it's just going to run around the profile to put that groove into the part. All right, we'll run this through a simulation real quick and kind of go from there. Now, are you guys using profiling often? I would expect that you guys would be using this quite often. If you have any questions about the profile feature or things that you're unsure about, just go ahead and ask. It'd be great to get some feedback from you. If you guys are super happy with the profile feature now and can't see anything else being added to it, you could let us know that too. All right, so here I'm going to play this through, and you can see how we can come in here and we can do this undercut on this boss here. This could be a thread relief boss. That could be a tapered thread or something. Mike says I use it all the time. Absolutely. Okay. So that, again, is just a standard profile with some different tooling. The other thing I want to do here is I want to, I'm going to just sketch some lines. Okay. The next one that I want to talk about is actually called contour ramping. And there's a lot of different ways that you can use contour ramping. Let's remove this geometry. Let's reselect this line and this line. Okay. And then instead of jumping ahead, I'm just going to look at the directions that I have them going. I'm going to set this one this way and that one that way. 1/4 inch is fine. I'm going to change my tool from a T cutter I'm going to go to I really want a ball mill. Let's see here. It could be a ball mill. It could be a flat bottom tool as well. Let's just add one real quick. Okay, and we'll go corner radius, 1/4 inch. Okay, so this time we're going to use side roughing. What we're going to do a little bit differently is we're going to, Michael, you can use this version on BobCAM. That's correct. I'm going to go to contour ramping instead. This is where you get a ramp profile, so it'll ramp back and forth. In this example, I want to do a centerline slot, so I'm going to turn my system compensation off. I'll come down to my parameters. I can either give it an angle, so I could tell it an angle to come down on it, or I could give it an increment per pass. So I'm going to say 3 degrees is fine. I'll recompute. Let me get rid of the leads. So I'll go to my leads and turn it to vertical and compute. And then what this will do is give you a zigzag profile. So the tool is just going to work back and forth to work its way down there. All right. So let me see here. This, I did a pocket down a 1/2 inch. So let's change this. Our top of job is going to be minus 0.5. Our depth is going to be a 1/4 inch. And then our rapid plane, anytime I do a top of job, I add that number here. It makes sure that the tool has plenty of clearance as it moves around the part. All right, everything looks good there. We'll run this through the simulation again and take a look. How do you change the direction of the selected geometry? Okay, so that's a great question. Changing the direction when you select a profile, well, give me just a second. Let me simulate this first, and then we'll get into that. So we'll do next stop to move past the first simulation. I'm going to turn the tool path off, and then you'll see this is just going to give us a ramp back and forth to get down to the bottom. Okay. So again, using the contour ramping as a way in which you can ramp the tool back and forth. Why didn't the ball mill come up for selection? Tim, the ball mill didn't come up for selection because in the tool page, under our tool crib, there's just an end mill rough or an end mill finish. And then how that determines whether it's a ball end mill or a bull nose or an end mill, like a sharp end mill, is based off of your corner radius. If your corner radius is 0, now you have an end mill. If your corner radius is, some value less than the radius of the diameter, then you have a bull nose. And then if it's for the radius of the diameter, then you have a ball mill. And that's how that works. Okay. Now, I know Reginald had a question. How do you change the direction of the path? Well, in the feature here, there'll be a default chain start point. Okay. If you right click on that and choose modify, then these arrows will come up with your direction. And those arrows determine which way you're cutting. Okay. So if you click on one of the arrows, you can change which direction it's cutting in. And you'll use this for outside cutting and inside cutting. So hopefully, Reginald, let me know if that answers your question. Tim, let me know if that answered your question about the ball mill. Mike, is cutter comp, if the cutter comp is off, will the side allowance still work? Yes, if you have a side allowance, so I have cutter comp, system comp turns off, which means BobCAD will not offset for the cutter. And machine comp is turned off, so I have no G41, G42. If I come in here and I say side allowance of a 1/4 inch and I recompute, no, it did not move. Okay, I guess I'm wrong about that. Yeah, if you turn cutter comp off, it won't, system comp off, it won't move off the line. I apologize about that. I expected it to, and it did not. So under side allowance here, under parameters and side allowance, if you have your system comp off, it is not going to affect, it's not going to move that tool. Okay, so that's a good point you brought up there, Chuck, or Michael. Thank you. Let's see. Chuck had a question. Is the end mill tool crib, in the end mill tool crib, how do I get the list to go from small to large as a default. I don't think you can set the default in the tool crib. When you're in here, the tool crib, it will be numbering. So you can sort by numbering. You can sort by label. You can sort by size. But I don't think you can set the defaults for that. That's something that's done in the background. Okay. Let's see here. You did it when you were selecting geometry. Yes, the workflow is a little bit different, Reginald. When I go to select geometry, in the version 30, there's a different selection manager than there is in the BobCAM V6. So it is a little bit different there, but if you're in version 30, we use the selection manager where you can change the start and stop directions. I don't believe that's made it into the V6 yet, but you can look forward to that in new versions. Hey, Eric, thank you so much for joining us. Good to see you here. Okay, so we're on a profile here. We have we're doing contour ramping, so the tool's moving back and forth. That is a great tool to use for slots. Okay, if you have larger slot, I mean, here I have just centerline slots that I'm using. You could have, let's say it's a 5 by, you might have a slot like this that you want to machine. Okay, so we can remove that geometry, reselect this one here. We could come in and look at our tool size. So we have a 1/2 inch. That should be fine. We have our parameters, contour ramping, comp, we're going to set left. We'll recompute. And then this one here, you can see how the tool is going to work its way down to the bottom and then around. Now, it's important to understand that contour ramping isn't just for slotting and things like that, though it does work well for that, O-ring grooves, things like that. You can also use it to rough your part out as well. That's another useful tool depending on your part geometry. So here we can see it ramp down to the bottom, and we were able to cut that slot over there. Okay. So again, you have slotting. If we had an O-ring groove or something along those lines, we could select, this shape here. Let's change our tool size to, a smaller ball mill. Let's just turn it off. Let's see here. This is going to be 0. And this is going to be something like that. Okay, so this will just come in and it's going to ramp down and then run around and come back out. Okay, so that's another good option for you if you have an O-ring groove or something along those lines. All right, so we have our open pocket to clear the majority of the material. Then we're going to come back and we might have a groove that we want to put on the top of this, so we can have the tool ramp down in there. And then once it gets down to depth, it can continue to move around. And then now we have that nice groove there. Okay. Chuck has let's see, will ramp work on non-cutting, center cutting end mill? I guess it's possible, Grant, if you have, because you have to look at the teeth and if there's a pilot hole there. So it is possible that you could use ramp on non-cutting or non-center cutting tools. I don't know that I can answer that in all scenarios, but I think in some scenarios you could get away with it. Chuck has a question here. In the main tool library selection, the original tool, I always have to pick on diameter to get them in the right order. Chuck, if you have more suggestions or feedback about how you'd like the tool library or the tool crib to be formatted, what I would do is go to our homepage on BobCAD, and there's a report section all the way down at the bottom. Just put a report in with what you'd like to see in the software, and it'd be great to get your feedback. That is where all of our improvements come. So take the time to fill out a request, and you'd be surprised at how quick it could get into the software. Okay, so all right, so we did a profile there. Let me close this out. So we did an O-ring groove. We did some undercuts. Let's get into number 8 here. Okay, so number 8, I have this this pocket here. So what I'm going to do is remove, reselect. We'll select this shape to begin with. This one we're going to do a 1/2 inch deep. This is going to be offset out. We'll recompute. That will give us our pocket there. And then with this one, we're going to come in and do the wall. But instead of using just a regular end mill, we're going to come in and we're going to add a tapered end mill. All right. So we have a tapered end mill here. Leads, we're going to do our tangent here. We'll recompute. Seems like a very weird profile there. So let's go to 0.5. Okay, so this is ramping. I don't want it ramping, so let's go to just standard to begin with. This is an example of how you could use a tapered tooling in order to do like a tapered walled pocket. Okay, so let's run this through simulation again. You're welcome, Chuck. We'll run this through simulation. We'll go to the next op here. Okay, so we removed the bulk of the material, and then now what we want to do is use a tapered end mill to come in here and just put some draft on the wall. All right. I must still have cutter comp off because you can see it's taking a very aggressive cut right on the wall there. But that's the idea. If you have a drafted angle, you can always use a profile tool in order to come in there and put draft on the wall. Let me come back to our parameters. We'll turn system comp back on. We'll recompute. Now you can see the tools on the right side of the line are offset properly. The other thing you might want to do when you're doing a tapered pass, again, you may come into the side roughing. You could say there's a certain amount of material and I want to take it in a certain number of passes. And then this way you can walk the tool into that profile versus just taking a very aggressive cut. Okay, so we'll go next on our pocket here, and then what we can do is step through, and you can see with this tapered end mill, we're able to come in here and to put the draft on the wall. And because we're taking 2 passes, we're not going to overload the tool. And again, I guess that would depend on how much draft was on the wall. But using your different tool types, you can attack these different scenarios. Okay, so that's an example of doing a tapered walled pocket where you're taking multiple passes. Let's look at the next one here. Okay, so this one, let me blank both of these. So this one we have okay, so we need to set up our pocket first. So I'm going to remove my geometry here and reselect. We'll select the outside shape, and this shape. Okay. So those are the areas that I want to remove material from. And because we're going to do, we'll do an advanced pocket, and that way we'll be able to clear all that material. So we'll recompute here, and that will clear the material, leaving these 2 bosses sticking up. And then from there, what I want to do is I want to come in and I want to create an undercut here. So again, I'm going to remove, reselect. These are the areas where the undercut is. Okay, we're going to come in and we'll change our tooling. Instead of a tapered mill, we'll go to our T-cutter again. All right, we'll go to our parameters. We're going to do, all right, let's just do 1 depth to begin with. Our leads, we're going to do, this is fine. Let's add an extension here and compute. Okay. So right now, they're cutting on the wrong side. So we'll go to our start direction here, and we're going to just set what direction we want them to go in. Okay. Get them cutting in the right direction and recompute. And then what this tool is going to do is it's just going to come in there and it's going to create an undercut at that section. Let's run this through simulation again. A lot of times you might have a wood drift type cutter. There may be a radius on that edge. And we're coming in here and we want to add like a relief. So here you can see we have this relief to come in here down at the bottom. If we need it to be greater, It could be greater, so we'll do like a parallel. We'll make it a little bit further in here. We might want it to start at a different area. So let's select these two here. All right, we're going to remove, reselect this one and this one. We'll check our directions here. That looks good. We'll set our top of job at minus 0.25, and then we'll set our bottom of job at 0.25. And then from here, we're going to edit our parameters, and we'll say multi-depths and compute. All right, so now we'll get 2 passes coming down. Let's it looks like I still have it set to ramp. Let me edit that. This is going to be standard. Okay, and run this through. Hello, Sebastian. How are we doing today? Okay, so we got our pocket leaving our bosses standing, and then we're coming in here with our T-cutter, and we're just creating an undercut here. Again, that could have a radius on the edge of the part there, but this is going to come in and leave some area for you in that particular section. Okay, so if there's any questions about that, go ahead and fire away. Otherwise, let's take a look at the next one. All right, so we got this one set up. All right, so here, this is another scenario. Let me let's turn this one off. Okay, let's remove this geometry. So here we have a block, and we want to clear a bunch of this material. So another way you might do this is with side roughing, where you'll select this edge of the part. Let's reverse the direction. Okay, we're gonna use like a larger mill. So we'll come in here and mill rough. I don't know, we'll say like sure, one of these. Okay, we'll start with a standard profile. Leads, we're gonna make parallel. And we'll recompute. Okay, so if you did this with just a standard profile right now, the tool is going to come in and clear just a portion of that material. And what you may want it to do is to actually machine quite a bit more. So let's run this through a simulation. We'll see how this is going to take, 2 passes here. Pretty aggressive, but really we want to remove all of this material as well. And this is another example of where you can use your side roughing. So we'll go 0, 1/4 inch. We'll come into our side roughing. This is, there's going to be 3 inches of material left. And then I can say I want to take that in 4 passes, and we'll recompute. And then we can simulate this. So you can see using the side roughing, you can, use it to profile down material where you may need to clear a greater angle. And then instead of doing a pocket or like an open pocket, you may find this type of tool path to be quite a bit easier to work with, and it may even be more efficient. Again, it depends on the part that you're working on, and it depends on your tooling. Okay, the size of the tool that you have and how efficient you're trying to get in there. All right, so let's close that one down. Let's take a look at the next one here. Okay, so this is another scenario where we're trying to let's blank this out. Let me blank. Okay, so this is another scenario where we have an elliptical or irregular shape, and what we want to do is use like a ramping routine to clear all the material to keep the tool engaged, So we'll remove our single line here. We'll select our spline, or I'm sorry, our ellipse. We'll make sure the tool is cutting in the right direction. We can recompute here. Maybe what we want to do, well, I mean, that's one way that we could do it. Let's say 1 and 2 inches. You may use side roughing to clear a boss down as such. So instead of a pocket, you may use a larger tool to clear material around the boss. Again, this isn't always the most efficient way because you're not targeting all the material like you would in an advanced pocket. But what's useful about this is you get very consistent tool paths. So it cuts, offsets, works its way in, cuts, etc. And it's very consistent. You're going to get a consistent result. So this is another example of where you can use side roughing in order to work your way into the part. Okay. All right, so let's stop that one for a second. Now, another way or another scenario that you might run into is where you're ramping in this. Instead of doing a side rough, you may use contour ramping. And this, again, is a way to keep the tool engaged into the material and, just ramp its way to get down to the bottom. Let me change my leads real quick. So we'll go vertical and recompute. And then what you'll see, like if we go to a front view here, you can see how it ramps to get down to the bottom. And then once it does get down to the bottom, what it will do is take a full pass while it's down there at the bottom. Okay, let's see what else we have here. Probably a better example for this is if you had a circle like this where you wanted to come in here, remove, reselect, where you just wanted to come in and do some helical milling. You could use contour ramping for helical milling. Okay, so that way the tool will helix down to the bottom, do a full pass at the bottom, and then come back up. What are the differences between rough profile and finished profile? That's a great question. If you're in here, here, let me do a new one. So I'll do a new feature here. We'll do 2-axis. And you'll notice that by default, there's a rough profile and a finished profile. And really, there is no difference per se other than the patterns. On a profile finish, the default would go to a finished tool. And then the default would go to a finished tool. And then also, it would only have a single profile pattern. Okay, so you only have one pattern, where if you're in the rough profile, you can see you have the standard, the contour ramping, and the side roughing. Okay, so that's the difference. The finish pass doesn't give you the same patterns that you could use. The other thing is the finish pass, really that's it. You can take multi-steps with a finish pass. You can leave bottom and side allowance with a finish pass. The only difference is really the patterns. You don't have the same 3 different patterns that you could work with. Okay, Reginald? All right, very good. Hello, Sabrina. How we doing? Okay, so, all right. So if we look at let me delete this guy out of here. If we look at our profile here, we selected our geometry. And again, contour ramping, you can use this for helical milling to mill out circles and holes and things like that. To use cutter comp to set the tool diameter, are there guidelines as to the length of movement needed to allow cutter comp to activate? So Larry's talking about your lead in and lead out. And generally, for the BobCAD system, in order to post a lead in and lead out, you're going to have to use, you can't do a vertical lead in. You're going to have to use like one of the circular lead ins so you get a line arc move. And generally, the line arc move, the radius, like the distance out needs to be greater than the radius of the cutter. Otherwise, you're going to get an error or an alarm on the control. Some of the ways that people will bypass that, because sometimes you don't have room for a very large lead-in, Larry. So what you'll do is you'll let BobCAD offset for the cutter. So half the cutter is already offset, and then you'll use machine comp as really more of a wear comp. There's a couple of scenarios that you deal with here. Either BobCAD doesn't offset for the cutter at all, which would be system comp off, and then you let the machine do the compensation, which would be G41 or G42, depending on what direction you're going. Okay. In this scenario, the diameter value on your control would be, or the radius or diameter value, it's going to be for half your cutter. Okay. If you have system comp on left and you're running comp left, now the value for your comp, the amount the control would offset for, is typically more of a wear comp. So it's a smaller value or an adjustment value. Okay. By doing this, it allows you to use a smaller lead in. If you are not offsetting for the tool and you're using cutter comp, then your lead in needs to be much, much greater. Good description of cutter comp. Thanks. All right, cool, Robert. Glad that we could help with that. All right, so let's see what else we got. Hopefully that answers your question there, Larry. Greater than the radius of the cutter is what you're looking at. And then the last one here, again, I just have like a irregular shape. So I'll remove and reselect this shape here just to show you that the helical ramping is not limited to just circles. You could use this for a variety of different shapes. A lot of times it's a really easy way to remove material from the outside. I hope you guys are enjoying the webinars. We got just about 5 minutes left here. Boy, time flies when you're having fun. So let's push this through. But again, the takeaways for today are you have a standard profile, you have contour ramping, and you have side roughing. And there are a number of different ways that you can use those tool paths to machine different aspects of your parts. The other major takeaway is when you look at your tools, you have tapered end mills you can use for draft on your parts. You have dove mills you can use for negative drafts. You have lollipops, T cutters, so there's all these different types of tools that you can use depending on the application that you have. The other takeaway is when you're selecting your geometry, if you need to change where the tool lead in and lead out from and the direction of the path, this is under default change start point. You can right click and modify, and then to change the direction, you just click on the arrow and that will change what direction the tool is cutting in. Yay! Webinars are great. Hey, Tony, thank you so much for showing up here today. Hopefully you're enjoying today's Webinar Wednesday. Again, I want to thank each and every one of you for spending some time with me here today. Those are the topics that I had to cover. Unless you guys have any additional questions, what I'll do is shut down the webinar for today and look forward to seeing you guys in the next one. I haven't updated the webinar schedule. I had it updated to May. So I am interested in what topics you guys like to see covered. I know I have a lot of different feedback from the Facebook communities, but any topics that you guys would like to see covered in future webinars, go ahead and let me know what you're interested in. You can email me at al@bobcad.com. Thank you so much, Hugh, for joining us here today. And just if you have any sample files, if there's a project you were working on and you'd like a little insight or that you feel would help other users as well, definitely send over that file. Until then, I look forward to seeing you guys in the next webinar. Let's see here. And as always, with BobCAD, you can expect fewer steps, better cuts, and more profit. We are still running our Refer a Friend program. If you guys have a friend that's interested in the BobCAD software, you can go ahead and call this number, talk to one of our account managers, and they'll talk to you about how you get a free seat of our software when you refer a friend. Again, 877-333-4903. Look forward to seeing you guys in the next one.